All right, so this is section 4.4 of Math 146. We're going to continue the idea of the inverse trig functions. This is really just an extension of 4.3. What's going to be slightly different about this one is that we're going to talk about composites of different types of trig functions. So a sine of an inverse cosine or something like that. Um, and then we're also going to talk about how to find values of the inverse of cosecant, cosecant, secant, and cotangent, and the best way to do that. This will probably be one of the shortest sections that we do in the videos, so let's get to it. So from the last section, our first example here, we want to find the exact value of the sine of the inverse tangent of 1/2. Well, that is a 1/2. There we go. All right, so we still have to keep in mind our restrictions of our domain. Um, the general concept is we want to look at this and say, okay, I know that this part right here is going to yield an angle. We're going to get some kind of an angle out of this. So in order to do this one, we're basically going to sketch ourselves a right triangle. And what we should know is that whatever our angle is, we're going to call our angle theta here. The tangent is the opposite over the adjacent when it comes to the right triangle. So they're telling us that if I'm going to find theta out of this, that the opposite over the adjacent should yield 1/2 opposite over adjacent. So whatever that is, this is going to give us theta. So ultimately, we are going to take the sine of theta. Well, I have a right triangle set up here, which I can use to help find the sine of theta. Of course, to find sine is opposite over hypotenuse. I am currently missing the hypotenuse, but since we have two sides of a right triangle, we can use the Pythagorean theorem to find the missing side. So the missing side here would be 1 squared plus 2 squared, so that's going to be 5, and then you take the square root. So the missing side is 5, square root of 5. So the sine of theta in this case is going to be 1 over the square root of 5. Of course, rationalized, if you multiply top and bottom by the square root of 5, you would get the square root of 5 over 5. I am not going to require that you rationalize for this. However, I cannot guarantee that my math labs will not ask you to rationalize. So just in case, make sure you know how to do that. All right, let's do another example. Very, very similar. So let's find the cosine of the inverse sine of negative 1/3. Once again, this part right here is going to yield an angle. And again, we have to keep in mind that that there's going to be some domain restrictions here. So we're trying to find the inverse sine of negative 1/3. I'm still going to sketch a triangle. Now, I do this slightly differently because I don't feel that I need to put the triangle in its proper quadrant. Although the inverse sine of negative 1/3 we know should be in the negative first quadrant. But I don't really, again, I don't really feel the need to do that as long as we understand what it is that we're looking at. So this is still going to be my theta. Sine, once again, we know is opposite over hypotenuse. And so we're going to ultimately need that missing side because cosine requires the adjacent. So in this case, it's going to be the 3 squared, which is 9, minus 1 squared, which is going to give us 8, and then you take the square root. So the missing piece is the square root of 8. That's the adjacent side. And what we have to think about here is, since this is going to end up being in what would be the negative first quadrant, or the fourth quadrant if you think about its coterminal angle, then the cosine is going to end up being positive. So that's the biggest thing you have to realize here, is that this thing right here put us into that negative first quadrant, or the fourth quadrant, if you think about the coterminal, which means that ultimately the cosine value here is going to be positive. So if I take the cosine of the angle, that should be the square root of 8 over 3. And of course, you could reduce the square root of 8 to 2 square roots of 2 over 3. Again, I will not require that, cannot guarantee it would not be required for your MyMathLab. All right, let's do one more. One more example of this. So let's say we want to do the tangent of the cosine inverse of negative 1/3. Okay, so remember that cosine has inverse cosine has a restriction to being in the first and second quadrant between 0 and pi. So that fact that that is a negative 1/3 is going to put us into the second quadrant, but tangent is also negative in the second quadrant. So the answer that we get out of this for tangent of theta should give us a negative answer as well. Just have to remember that, because when I go to sketch this triangle over here, I'm not using the negative sign. I'm not putting this into the proper quadrant for my sketch. I just don't do it that way. So let's see, cosine is adjacent over hypotenuse. Okay, well, that's very similar to the one we just did. It just makes the opposite side, in this case, the square root of 8. And so let's see, tangent is going to be the opposite over the adjacent. So it's going to be the square root of 8 over 1, which is just the square root of 8. But again, it's now in the second quadrant, so tangent is negative there. So you could call that negative root 8 or reduced negative 2 root 2. All right, hopefully you get the idea. You just have to be careful as to what quadrant it's in, your theta value. So you have to determine it from this, where your theta is going to be, and then from that you can determine what the other function has to be, whether it's positive or negative. All right, now let's talk a little bit for the second part of this about how to find the inverse, cosecant, secant, and cotangent values. And it's very similar to what we did in the previous section, because we're going to ultimately utilize what we know about sine and cosine to do this. This is the way that I do it. I think this is the way the book does it. It's just probably the easiest method overall. So if I wanted to find the inverse cosecant of 2, remember, when you do an inverse function, you're trying to find the angle that would produce the value 2. I don't have my cosecants and secants and cotangents memorized. There's a couple values I might know very quickly, but what I do know is I do know the sine, cosine, and tangent stuff pretty well. So cosecant inverse of 2 is going to be the same thing, if you think of this in terms of reciprocals, as the sine inverse, and then you would have to flip over or take the reciprocal of the 2, which would be 1/2. These are going to give you the same location. Whatever that angle is will be the same thing. And that angle, where sine gives me 1/2, is going to be at pi/6. So the cosine inverse of 2 is going to give you pi/6. And again, remember that the domains for these things are going to be the same. So cosecant is going to be restricted, just like sine is, between negative pi/2 and pi/2. Secant, which is the reciprocal of cosine, will be restricted from 0 to pi, the inverses. And then cotangent, which is going to be the reciprocal of tangent, will be also restricted from between negative pi/2 and pi/2, just not including the endpoints. All right, so let's try one more of those. Let's do the inverse, the inverse cotangent of the square root of 3. Well, again, what I'm going to do is I'm going to, first of all, I'm going to use the reciprocal. And I'm actually, you don't even have to in this case, but I still think it'll be easier to think of this way. So we'll do the inverse tangent of 1 over the square root of 3. But of course it's tangent, and again, I don't have these memorized. You might at this point, which is great, but I think of this in terms of sine and cosine. So I'm going to think of 1 over the square root of 3 as the same thing as being 1/2 divided by the square root of 3 over 2. So if the sine is going to be on top and the cosine is going to be on the bottom, sine is going to give me 1/2 at pi over 6. Cosine would give you square root of 3 over 2 at pi over 6. So very much like the previous problem, kind of coincidental there, we are going to get pi over 6. And then let's just say, for example, that we wanted that to be the negative square root of 3. Well, then that would be the negative here, and then that would just drop that into the negative first quadrant. All right, so the only other thing that I'm going to mention here is if you have to do something like this in a calculator to get a calculator value, some calculators actually do have these inverse trig functions for secant, cosecant, and cotangent. Most of them don't. So in order to do it, basically you have to think of it as a reciprocal, because you might get one like this that says find an approximated value, because it's literally a calculator problem, of the inverse secant of 3. Well, in order to do that in the calculator, you would actually have to think of this as being 1 over the inverse cosine of 1/3. Excuse me, I don't know why I just did that. That was a double reciprocal. It should be the inverse cosine of just 1/3, not 1 over. I apologize. So that's how you would have to plug that in your calculator. If you actually just wanted to use the calculator to find a secant value, just not an inverse secant value, but a secant value, then that would be something where you would use 1 over. So let's just say we wanted to find the secant of, I don't know, pi 12ths or something like that. Then what you would do is you would type that in as 1 over the cosine of pi 12ths. Not really what we're doing in this particular section, but that's where I was going with my thought process on the other one. So just want to make sure we understand that. So if you want to find the inverse secant of 3, you really find the inverse cosine of negative 1/3, and you would just plug that in your calculator. Now keep in mind that the calculator is going to spit out the acute angle here for this. So they will give you whatever the standard acute angle is going to be. All right, I do believe that that is all we need to cover in section 4.4 here. So that should be plenty enough. When we come back with 4.5, we'll actually start talking about trigonometric equations and how to solve them.